Welcome to Paradox Lab. Everyone knows that the universe is vast, but exactly how vast it is has likely remained a great and fundamental question for astrophysicists since ancient times. In ancient China, the philosopher Laozi believed that the universe was an existence without beginning or end, infinite and boundless. However, by the 20th century, the development of microphysics and astrophysics allowed a new theory to emerge, suggesting that the universe had a starting point of formation, which is the Big Bang. The Big Bang theory is accepted by the majority of scientists in the world. But if we follow this theory, how large would our universe be? Let's explore this in today's video. Have a good time watching the video, and don't forget to subscribe to the channel and turn on the bell to always accompany Paradox Lab. Let's go explore. To make it easier for you to visualize the size of the universe, let's start from our beloved Earth. As you know, our Earth has an equatorial diameter of about 12,756 kilometers. If you had the idea of walking around the Earth at an average speed of about 7 kilometers per hour, and you walked 15 hours a day, it would take you about 381 continuous days to complete one lap around the Earth. Through this, you can see that our Earth is truly vast, isn't it? But it is nothing compared to the boundless universe out there. When we leave Earth, we will see that the Earth is indeed very small. For example, if you want to travel to the closest celestial body to Earth, which is the Moon, it is about 384,400 kilometers away from Earth, which is about 30 times the diameter of Earth. Of course, if you want to go to the Moon, you cannot walk. You need a rocket with a minimum speed of about 7.9 kilometers per second to escape Earth's gravity. If you fly in a straight line theoretically at a speed of 7.9 kilometers per second, it will only take you about 13.5 hours to reach the Moon. But naturally, spacecraft do not do that. To approach the Moon, a spacecraft needs several days to fly there. And when you arrive at the Moon, you will begin to feel that our Earth is very small compared to the distance to the Moon. Going further than the Moon, we come to the Sun, the only star in the solar system. If you still want to travel to the Sun using a rocket like how you went to the Moon, you would have to fly non-stop for 220 consecutive days to reach the Sun. Because the distance from Earth to the Sun is approximately 150 million kilometers. If you compare this distance with the Earth, our Earth is truly very tiny. However, the distance to the Sun is still nothing compared to the distance of the furthest planet in the solar system, which is Neptune. It is about 4.5 billion kilometers away from the Sun. If you still want to use a rocket traveling at 7.9 kilometers per second, you would need more than 17 years of non-stop flying to reach Neptune. And upon reaching Neptune, you will probably start to feel overwhelmed by the vastness of the universe. And at this time, we probably need a faster means of transportation. This is the Paradox Lab spaceship, which will take you to the farthest places in the universe. Naturally, it is equipped with future technology, flying at a speed equivalent to light, which is about 300,000 kilometers per second. If you use it to fly to Neptune, instead of taking more than 17 years like when using a rocket, it will only take you a little over 4 hours to reach Neptune. At this point, you might secretly rejoice because you have a very fast means of transportation, right? But don't be too happy yet. Let's use the Paradox Lab spaceship's speed of light to travel to the closest neighboring star to the Sun to see how it goes. Here it is, the Alpha Centauri star system, the closest star system to Earth. To travel here at the speed of light, you will have to fly non-stop for about 4.37 years, meaning you need to travel a massive distance of 41,515 billion kilometers. With this distance, if compared to the Earth's diameter, it is about 4 billion times larger. Now you are beginning to be overwhelmed by the vastness of the universe, but the distance to that neighboring star is nothing compared to the size of the Milky Way galaxy. As you know, our Sun is one of over 200 billion stars located in the Milky Way galaxy, and it has a diameter of about 120 light years. If you want to travel across it at the speed of light, you will have to take 120,500 years. This means that even if you have a spaceship traveling at the speed of light, if you travel continuously for 1, Zeus and generations, your descendants would still not be able to cross the galaxy. Is this the size of the universe? Definitely, the answer is no. This is only the size of our Milky Way galaxy. Out there in the vast universe, there are still many other regions. Passing the Milky Way galaxy, we come to the nearest neighboring galaxy, which is the Andromeda galaxy. According to scientists, the distance to the Andromeda galaxy is about 5 million light-years, meaning our spaceship would have to fly non-stop for 2.5 million years just to reach the nearest neighboring galaxy. If you want to calculate it in kilometers, take the number 2.5 million multiplied by 9, 500 billion to get the exact distance. If you are good at math, leave your comment below the video about the distance to the Andromeda galaxy. Upon arriving at the Andromeda galaxy, many of you will surely feel dizzy because of its extremely long distance. But you know what? We have only traveled a very small distance compared to the boundless universe. Because according to scientists' calculations, the universe could contain hundreds of billions of galaxies, similar to our Milky Way galaxy, a space that perhaps even the genius minds of humanity, like Albert Einstein or Stephen Hawking, could not imagine. Here is a distant galaxy located in the Ursa Major constellation, named GNZ11. This is one of the galaxies with the largest redshift ever discovered, with a redshift of 11.1, corresponding to a comoving distance of 32 billion light-years. Meaning this galaxy is about 32 billion light-years away from Earth. And of course, that is still not the largest distance in the universe. Scientists believe that the universe includes all existing matter, energy, and space. As for its actual size, it has not been clearly determined, but what we can observe has a diameter of about 93 billion light-years. This is called the observable universe, which is the universe that we can see. So a frequently asked question is, what is beyond that 93 billion light-year space? This question has truly challenged scientists, as even they themselves cannot imagine what lies outside that space. So going back to the initial question of how large the universe is, certainly up to the present moment, no one can answer it for sure. We are limited by the observable universe, with a diameter of about 93 billion light-years. When mentioning the observable universe, many of you will wonder why the age of the universe is 13.8 billion years. But the size of the observable universe is defined as 93 billion years since the universe started with the Big Bang. Because if this happened, it means two galaxies could move apart by a distance equal to 93 billion light-years after only 13.8 billion years. This seems to be a paradox according to Einstein's theory of special relativity, which states that no material object can be accelerated to move faster than the speed of light. If the universe operated according to special relativity, this would definitely be an impossibility. However, his theory of general relativity points out that space can expand without encountering any intrinsic speed limit, and thus, two galaxies can move away from each other faster than the speed of light as the space between them stretches out. And this is the reason why galaxies can move away from each other faster than the speed of light. The cause of this event is the expansion of the universe. Up to now, due to the limit of the speed of light propagation, we can only observe a small part of the universe called the observable universe. When the majority of astronomers use the word universe, they mean the observable universe. Because since we cannot observe the space outside, we cannot affirm whether the universe is infinite or finite. Both of these possibilities can happen. Hopefully, in the near future, scientists will be able to answer the question of how large the universe is so that we can have the most accurate visualization of the universe we live in. The Sun is the only star in the solar system, the source of warming energy for the planets, including our Earth. This is a giant plasma sphere heated to incandescence thanks to nuclear fusion reactions in its core. According to calculations, every second the Sun fuses about 600 million tons of hydrogen into 596 million tons of helium, meaning it converts about 4 million tons of matter into energy every second. This massive source of energy radiation becomes the source of light and heat spreading throughout the solar system. Besides heat and light radiation, the sun constantly spews out a layer of charged particles called the solar wind. When these electromagnetic particles reach Earth, most of them are blocked by Earth's invisible shield, which is the Earth's magnetic field. When charged particles from the sun enter the Earth's magnetic field region, they will slide towards the poles, causing the beautiful auroral phenomena that we often see. Precisely because of Earth's magnetic shield, ordinary solar winds seem to be blocked and do not affect electronic devices on Earth. But when the sun acts up, it emits larger and stronger solar winds known as solar storms, which usually appear during violent solar flares. On the surface of the sun, whenever there is a temperature difference around an area, sunspots will appear. These sunspot areas are the source of powerful magnetic flares, creating massive explosions on the surface in a short period of time that might only last a few minutes. But the matter in this area is heated to millions of degrees Celsius, releasing a large amount of magnetic particles into space, creating solar storms. Then it starts moving in space, attacking directly. And naturally, strong solar storms can pierce through Earth's magnetic shield, directly affecting life on the surface. At the SIGCOMM 2021 Data Communication Conference held in late August in the US, researchers from the University of California warned that the next solar storm could arrive at any time. It would cause a worldwide internet outage, and that situation could last for several months. Researchers said a severe solar storm could plunge the world into an internet apocalypse, causing many people in society to lose internet for weeks or months at a time. They compared it to an unexpected pandemic for which humanity is not prepared, and that very surprise could leave us unable to react in time. In fact, such extreme solar storms do occur. Scientists estimate the probability of extreme solar storms directly impacting Earth fluctuates between 1.6 to 12% per decade. This shows it is very difficult for humans to predict when a solar storm will appear, thus making response even more difficult. The most recent solar storm appeared in 2014, however. Its destructive power was not severe. In history, only two major solar storms have been recorded, one in 1859 and one in 1921. Among them, the 1859 storm is considered the strongest ever recorded in history, also known as the Carrington Event. This was the first solar storm recorded in the world and also the largest recorded in the past 500 years. At that time, Earth's magnetic shield was defeated, causing the solar storm to directly affect life on Earth. Consequently, at that time, telegraph systems in Europe and North America completely collapsed. Telegraph equipment emitted electric sparks, shocking many operators, and compasses worldwide were reportedly disabled. It seems the solar storm back then severely affected the technology of 1859. Since then, human civilization has become much more dependent on the global internet, building cable systems and satellite systems that help humans connect with each other. But so far, our technological infrastructure has never had to endure the impact of massive solar storms. Therefore, predicting the damage that would occur is very difficult. The most obvious thing is that it could disrupt the internet for a long time. But fortunately, local and regional internet connections have a low risk of damage because fiber optic cables themselves are not affected by geomagnetically induced currents. However, submarine internet cables connecting continents are a different story. These cables are equipped with repeaters to boost the optical signal, spaced about 50 to 150 kilometers apart, and these repeaters are very susceptible to electromagnetic currents. Entire cable lines could become useless if they encounter a large solar storm. If submarine cables break down in a certain region, continents could have their communications interrupted. Furthermore, countries at high latitudes, such as the US or the UK, are more vulnerable to space weather than countries at lower latitudes. In the event of a catastrophic solar storm, countries at high latitudes would be affected first. If that happens, it is hard to predict how long it will take humans to fix underwater infrastructure. Therefore, predictions of internet outages lasting several weeks or months are well-founded. Of course, with our current lives, we heavily rely on global internet connections. If a disruption occurs for a long time, millions of people could lose their livelihoods, and it would cause no small impact on the global economy. According to forecasts, in the US alone, if the internet is disrupted for one day, it could cause damages up to $7 billion. And if the situation prolongs for a month, the damage figure could be multiplied many times. Just imagine if that disruption occurred on a continental or global scale, the economic damage would be unimaginably terrible. For this reason, scientists believe it is time for us to seriously consider the threats of space weather impacting human life. Naturally, predicting space weather with current technology is impossible because we do not yet have the capability to calculate space weather. Therefore, humans can prepare response plans in advance to minimize the damages caused by solar storms. But what are they? Placing many submarine cable systems at lower latitudes or building other magnetic shields for protection will definitely be a massive problem for planners in the future. We cannot predict when a solar storm will occur, but once it does, humans still have about 13 hours before the solar storm reaches Earth, and that will be precious time for scientists to come up with the best response plans. Therefore, observing and monitoring the sun's activity is extremely important, helping humans understand more about solar storms so we can forecast them accurately. Jupiter is the 5th planet from the Sun and is the largest planet in the solar system. This is a giant gas sphere with an estimated mass about 2.5 times the combined mass of all other planets in the solar system. Therefore, Jupiter is always considered the big brother of the solar system. Jupiter takes about 1186 Earth years to complete one orbital cycle around the Sun, while it takes about 9 hours, 55 minutes, and 30 seconds to complete one rotation on its axis. Because of this, although it is the largest planet in the solar system, it is also the planet with the fastest rotation speed. The rotational velocity at Jupiter's equator reaches up to 12.6 kilometers per second, equivalent to about 45,000 kilometers per hour. Because of this, it is considered one of the harshest planets in the solar system. The period from 2009 to 2020 was a time when Jupiter was in the most suitable position for telescopes to observe the Great Red Spot. Therefore, NASA conducted a series of observations of the Great Red Spot from the Hubble Space Telescope during this time. The results showed a very interesting thing, which is that the wind in the outer ring of the Great Red Spot has increased its speed by 8% at the present time. Scientists frequently measured wind speeds in the outer ring, surpassing the mark of 100 meters per second, which is greater than 360 kilometers per hour. Meanwhile, about a decade ago, the wind speed in this area was only about 90 meters per second, equivalent to approaching 324 kilometers per hour. This shows that the wind speed in the outer ring of the Great Red Spot is accelerating over time. This must be said to be incredibly terrifying wind speeds. On Earth, there seems to be no storm that can reach such wind speeds because the strongest wind gust on Earth can be recorded up to Category 17, meaning gusts over 220 kilometers per hour. This number is still very modest compared to the wind speed of 360 kilometers per hour in the outer ring of the Great Red Spot. Upon discovering the increase in wind speed in the outer ring of the Great Red Spot, scientists tried to figure out the underlying cause of this event. But unfortunately, the Hubble Space Telescope can only observe from above and cannot see deep into the storm. Therefore, scientists do not know what caused the wind to accelerate over time. Scientists are looking forward to data from NASA's Juno spacecraft, as it is equipped with tools to peer deep into the storm to map it. This is the spacecraft launched into space by NASA in 2009, and it is currently still orbiting Jupiter. Of course, during its operation, Juno only occasionally has the opportunity to look deep into the storm because it doesn't always get close to that storm. Therefore, scientists need to synthesize more data over many years to be able to provide suitable explanations for the acceleration of wind in the outer ring. Not only is there a change in wind speed, but the outer ring of the Great Red Spot is also shrinking in size over time. According to a report from NASA's Jet Propulsion Laboratory, Jupiter's Great Red Spot is gradually shrinking, and could disappear entirely within the next 20 years. According to statistical data, the Great Red Spot has shrunk by about 17 degrees since 1800. At that time, the Great Red Spot had a size of about 56,000 kilometers, which is about 4 times the diameter of Earth. But currently, its size is only about 1.3 times the diameter of Earth. Therefore, sooner or later it will disappear on Jupiter, which is perhaps an inevitable consequence, as no storm can last forever. According to scientists' calculations, the Great Red Spot may have existed on Jupiter for about a few 150 years. Even though its size has shrunk at present, it is still the largest storm in the solar system that we can observe. According to scientists, an oval located at the center of the Great Red Spot rotates counterclockwise with a cycle of about 6 Earth days. The highest clouds in the storm are about 8 kilometers taller than the surrounding clouds. If one day Jupiter's Great Red Spot disappears, many believe another Great Red Spot will take its place. In May of last year, a new storm was first discovered on Jupiter by amateur astronomer Clyde Foster. This storm was located right next to the massive Great Red Spot storm, and after its discovery, to honor the first person who found it, scientists named the storm after the amateur scientist Clyde Foster. Looking at the screen, this is the image captured by the amateur astronomer, and initial records showed this storm had just appeared on Jupiter not long ago, because during flybys of this area before May 2020, the Juno spacecraft did not detect the storm. Therefore, it is definitely a newly formed storm right after the amateur astronomer discovered it. Juno also captured an image of the storm, and this is the image Juno sent back to Earth. Scientists added that they will observe and study this new storm more carefully to gain more understanding of Jupiter's activities and potentially answer the question of whether a new storm has enough power to replace the Great Red Spot if it disappears. To be fair, among the planets in the solar system, Jupiter remains one of the most remarkable. With the supermassive gravitational pull of a gas planet 318 times heavier than Earth, Jupiter acts as a focal point attracting asteroids and meteorites toward it. Thanks to this, inner planets like Mars, Earth, Venus, or Mercury are much safer. Many people believe Jupiter is a silent protector of life on Earth. But of course, not everyone agrees with that view. In early 2020, Professor Dr. Kevin Grazier, a renowned astrophysicist teaching at various universities in the US, revealed that Jupiter does not always suck up every object as a protector. Sometimes, its immense gravity deflects celestial bodies and accelerates them into the inner region. This means Earth and the inner planets might be at risk of getting hit. That is why the doctor believes the giant Jupiter has a double-sided life. On one hand, it acts as our bodyguard, but on the other hand, it inadvertently accelerates celestial bodies and redirects them toward Earth. Scientists are considering more details to see if the giant Jupiter helps us more or destroys us more. Let's wait and see how scientists will announce the true nature of Jupiter in the coming time, whether it is a real bodyguard or a destroyer. As for the discovery that the winds in the outer area of the Great Red Spot are accelerating, and the size of the Great Red Spot is shrinking, perhaps this is an inevitability of nature. Hopefully, when the Great Red Spot disappears, there will be another Great Red Spot to replace it, so that whenever we observe the largest planet in the solar system, we can admire the characteristic storms on the giant gas planet Point 4. 6 billion years ago, when the Sun was newly formed, our solar system had only a young star at its center, surrounded by a protoplanetary disk. Within this protoplanetary disk existed many meteorites, ancient asteroids, as well as Trojan asteroids. These are considered the primitive materials that formed the planets as we see them today. After the planets formed, the Trojan asteroids still existed, and they were mainly captured by the gas giant Jupiter. Therefore, scientists found many Trojan asteroids in Jupiter's balanced orbital regions. Among them, one group of Trojan asteroids travels ahead of it, about 60 degrees away from Jupiter, while the remaining Trojan group trails behind it, also 60 degrees away. All of these Trojans seem to lie on Jupiter's orbital axis, with an average distance from the Sun of 5.2 astronewton, similar to Jupiter's orbit. So far, Astronomers have catalogued about 7,000 Trojans, but their actual number will be much higher. Their population might even rival the main asteroid belt located between the orbits of Jupiter and Mars. Because they were formed at the same time as the solar system, Trojan asteroids are thought to hold important clues about the history and development of the solar system. If humans can decode those clues, we will have important keys to the formation and development of Earth, as well as other planets in the solar system. To do that, scientists will assign tasks to spacecraft, and NASA's Lucy spacecraft is a pioneer tasked with approaching Jupiter's Trojan asteroids. The spacecraft is named after human ancestors, the ancient fossil Lucy, which is the oldest human fossil ever discovered, estimated to date back about 3.2 million years. With this mission, the Lucy spacecraft will revolutionize our knowledge about the origin of planets and the formation of the solar system. It could even tell us about the origin of organic materials, which are the first clues to life on Earth. Specifically, NASA designed the Lucy mission as follows. Regarding the surface geology, Lucy will map the spatial distribution, crater shapes, and size frequencies, determine the nature of the structure and crust, and simultaneously determine the relative age of the Trojan asteroids. Lucy will also map the colors, compositions, and intensity characteristics of the asteroid surfaces, and calculate the distribution of minerals, rocks, and organic minerals, if any. Regarding the interior of the asteroids, Lucy will determine the mass and material density while studying the subsurface composition through craters and fractures. Furthermore, it will search for satellite systems of the Trojan asteroids, if any. According to the plan, the Lucy spacecraft will begin its space journey this coming October. Specifically, Lucy is scheduled to launch atop an Atlas V rocket from the Cape Canaveral Space Force Station in Florida on October 16, 2021. The spacecraft's mission will last for about 12 years, meaning the ship will operate and complete its mission by 2033. During that time, Lucy will visit 7 different Trojan asteroids and 1 asteroid in the main belt. Here is a description of Lucy's path. Its complex orbit will bring the spacecraft to visit both the leading and trailing Trojan swarms of Jupiter. With a complex orbit and 8 destinations, Lucy becomes NASA's record-breaking mission for destinations. The head of the Lucy mission, Hal Levison, stated that they are visiting more asteroids than any other spacecraft in history. Indeed, no other space mission has ever been conducted with so many destinations. For the first time, Lucy will show us the diversity of primitive celestial bodies, the first building blocks that formed the solar system. Mr. Levison also revealed another record for Lucy, saying they will travel further from the Sun than any other solar-powered spacecraft in history. This means Lucy will break the record of the Juno spacecraft, which has been orbiting Jupiter since July 2016, to become the solar-powered spacecraft traveling furthest from the Sun in history. Lucy's mission will go to 7 Trojan asteroids and 1 main belt asteroid. But first, it will fly by Earth twice to borrow gravitational pull, before starting its journey to the asteroids. Expected in April 2025, Lucy will perform a flyby of its first asteroid. That asteroid is designated as 52246 Donald Johanson, also known as Asteroid 1981 EQ5. This is an asteroid discovered in 1981 and has a diameter of about 4 kilometers. After approaching this asteroid, Lucy will approach 4 other asteroids between August 2027 and November 2028. After that, Lucy will travel to the trailing swarm, where it expects to rendezvous with 3 space rocks in March 2033. According to the plan, Lucy will not linger at any asteroid target. It will merely fly by within 1,000 kilometers of the surface. During its exploration, Lucy will always maintain a speed of 5 to 8 kilometers per second, equivalent to 18,000 to 28,800 kilometers per hour. Therefore, the encounters will happen very quickly. Crucial data will be gathered hours before and after the closest encounter takes place. Lucy is also equipped with different cameras and spectrometers to make data collection as efficient as possible. In terms of design, Lucy is a spacecraft over 14 meters tall, but most of that consists of 2 giant solar panels. each over 7 meters in diameter, providing power to the spacecraft when it flies out to Jupiter's orbit. The mass of the spacecraft unfueled is 821 kilograms, and its mass when fueled is about 1,510 kilograms. The ship communicates with Earth through a high-gain antenna system, and in addition, it is equipped with 4 instruments to support remote sensing. The first is a color imaging camera and an infrared spectrometer, allowing the spacecraft to see multiple spectrums. The second is a high-resolution camera tasked with gathering the most detailed images of the surfaces of the Trojan asteroids. The third instrument is a thermal emission spectrometer. This infrared spectrometer will allow the Lucy team to learn more about the properties of the Trojans, providing us with the composition and structure of materials on the surfaces of the asteroids. Additionally, Lucy will be able to use its antenna to determine the mass of the targets by using the Doppler shift of radio signals. Lucy can also use its terminal tracking cameras to take wide-field images of the asteroids. Laurie Glaze, the head of the Planetary Science Division, said NASA is committed to funding the Lucy project with a total amount of $981.1 million USD. That money will carry Lucy through its primary mission in 2033. Currently, the spacecraft is ready for takeoff, and final preparations are being completed. Over the past 2 months, the engineering team has rechecked Lucy's functions, installed the antenna, fully fueled it, and prepared to pack it into a capsule before launch. The Lucy project manager said a lot of work was done over the summer, which passed very quickly, and it's hard to believe they are about to launch. That eager anticipation is not just his feeling, but perhaps everyone participating in the mission feels the same. After 6 years of living and breathing with it, now is the time they prepare to see their creation take off into space, carrying the dream of exploring the distant past of the solar system. Lucy will be an extended arm, a dancer gracefully moving around the asteroids, and we hope Lucy will endure through its 12-year mission and provide us with many new discoveries about the ancient asteroids of the solar system. Owning a space station of one's own outside in space is something any nation dreams of, but to turn that dream into reality is not something every nation can do. In order to build and operate a space station for many years in Earth's orbit, first, that country must have a developed space science and technology foundation, combined with the brilliant minds of engineers and talented astronauts. In addition to that is a solid economic potential. The clearest proof is the International Space Station, ISS. To date, the ISS is the most massive artificial structure that humans have ever operated in space, resulting from multinational cooperation, led by the space agencies of the US, Russia, Japan, Canada, and the European Space Agency. Without any single organization, the operation of the ISS would face many difficulties. But after many years of operation, the ISS is currently declining as it has exceeded its intended lifespan and frequently encounters emergency warning situations. Therefore, many countries have intended to build their own space stations to replace the ISS. As you know, China is not the only country planning to build its own space station. Russia and the US have also announced similar plans, but those projects only exist on paper. As for China, it seems they have moved faster. On April 29, 2021, China launched the Tianhe core module of the Tiangong space station into orbit, paving the way for the mission of building its own space station. A month later, on May 29, they launched the Tianzhou 2 cargo ship to the station. On June 17, the Shenzhou 12 spacecraft left the launch pad using a Long March 2F rocket, bringing the first 3 astronauts to live and work on the Tiangong space station. This is a historic milestone, as it is the first time the Chinese have sent humans to a space station built by themselves. The astronauts executing that mission were Ni Haisheng, 56 years old, Liu Boming, 55 years old, and Tang Hongbo, 45 years old. Their special mission on the station lasted 3 months, acting as a pivotal mission and representing the longest human presence for China in space so far. After 3 months of working on the station, recently on September 16, the 3 astronauts returned to Earth. They had a spectacular and grand landing flight to begin the journey back. The spacecraft separated from the Tianhe core module at 7:56 a.m. on September 16. This was the Shenzhou 12 spacecraft that brought the 3 astronauts to the station. At the time of separation from the space station, the Shenzhou 12 spacecraft was about 393 kilometers away from Earth, nearly the same distance as the International Space Station, ISS. After more than a day of leaving the station, at 12:34 p.m. on September 17, Hanoi time, the spacecraft landed in the desert area of Inner Mongolia, China. When it was 10 kilometers above the ground, the spacecraft was still moving very fast at about 200 meters per second, equivalent to 720 kilometers per hour, twice as fast as the fastest high-speed trains in the world. Therefore, slowing down the spacecraft was extremely difficult. Chinese scientists had to use a drogue parachute tasked with reducing the spacecraft's speed from 200 meters per second to 90 meters per second before the main parachute system was activated. This was a giant parachute about 70 meters long, which was the main device helping the spacecraft land safely, with an area of about 1,200 square meters. It helped the spacecraft reduce its speed from 90 meters per second down to 7 meters per second before the spacecraft landed safely. Although the speed had significantly decreased upon landing, when it touched the surface, the spacecraft still experienced a strong impact, causing dust and sand on the ground to fly blindly. Moreover, the engine underneath even caught fire. Very fortunately, the ground crew and medical staff were on standby, ready to support, taking the 3 astronauts safely out of the spacecraft. This was a historic moment when the 3 Chinese astronauts stepped out of the spacecraft. Their health was still good, and they even waved and answered television interviews right after landing. Ni Haisheng, the astronaut commanding the mission, shared his belief that with the continuous development of China's comprehensive strength and national scientific and technological level, there will be more astronauts setting new records and pushing China's activities in the space sector to new heights. Despite missing their families and relatives, the astronauts will have to undergo 14 days of medical quarantine before being allowed to return home, because their immune systems might have weakened after a long time operating in orbit. A special feature of this return mission was the support of the giant main parachute. The parachute was designed to save space and weight for the spacecraft. The parachute set weighed nearly 100 kilograms and was neatly packed in a space about the size of 2 suitcases. The parachute line material is light but very sturdy, consisting of 96 such lines. All the lines were carefully packed so they wouldn't tangle, because just a small mistake could cause the parachute to fail to deploy, severely affecting the landing. Chinese engineers stated that the parachute is only used for a short time during landing, but the engineers spent decades building it. During their time operating in orbit, the astronauts carried out many important tasks. The 3 astronauts conducted 2 spacewalks to install and check equipment on the Tiangong space station, helping the Tianhe module become more complete and ready for visits in the future. On July 4th, the first spacewalk concluded after 7 hours to install equipment outside the space station. The second spacewalk took place on August 20 for about 6 hours. Aside from working hours, they also exercised, trained their bodies, and maintained a healthy diet to reduce the effects of working in a microgravity environment. Before the Shenzhou 12 spacecraft separated from the Tianhe core module, the astronauts transferred experimental data back to Earth. Among them were beautiful pictures observing Earth from the space station. This includes a spectacular scene of thousands of lights in North Africa, taken by astronaut Tang Hongbo on August 30, 2021. And here is an image of a part of South Africa also taken by him in late August, followed by an image of the Peruvian coastline. Those are precious pictures after a 3-month business trip in low Earth orbit. Indeed, China's strong development recently makes people amazed. Right after the successful return of the astronauts, at 2:10 p.m. on September 20, 2021, China continued to launch the Tianzhou 3 cargo ship to the station. It was launched by a Long March 7 rocket. The Tianzhou 3 ship is 10.6 meters long, carrying thousands of kilograms of supplies, scientific equipment, and fuel to resupply the space station, helping the Tianhe core module prepare to welcome a new crew in the future. According to China's plan, they will continue to send 3 other astronauts to the space station in mid-October. They will also launch 2 more modules into space to dock with Tianhe, forming a 3-module station named Tiangong. According to the construction plan of China's Tiangong space station, in 2021 and 2022, they will execute 11 rocket launches to send the core module, cargo spacecraft, and manned spacecraft into space. It is expected that by 2022, China will complete the construction and officially begin operating the Tiangong space station. By then, the space station will have a mass of about 100 tons and enough space for 3 scientists to work long-term on the station. When completed, the station will have a T-shape with 3 modules, in which the Tianhe core module is in the center. It has a length of 16.6 meters, a diameter of 4.2 meters, and is the main living area for the astronauts. On the 2 sides are 2 laboratory modules helping Chinese scientists conduct scientific research on the station. With these dimensions, the Tiangong space station is evaluated to be equivalent to 20% of the International Space Station. China plans to exploit the space station for a period of 15 years. The Tiangong space station will operate in low Earth orbit. It is about 340 to 450 kilometers away from the surface. If after 2025, when the ISS International Space Station ceases operation and other organizations do not build another space station to replace it, China will become the only country with an operating space station in Earth's orbit. Of course, this is very difficult because Russia also intends to build its own space station. Besides that, the US and Western countries are also in the process of formulating plans to replace the ISS. Let's wait and see how organizations will execute their plans in the future. Regardless of political preferences, as many of us may not like China due to their expansionist policies in the region, speaking fairly about space science, they are indeed very good. Even though you might say their technology is a copy, mimicking Russia or the US, honestly, to copy and achieve such results is not a simple task. One can copy design concepts, but to put them into practice and operate them smoothly is truly top-tier copying. Once again, congratulations to China, and we wish their future missions to be successful. So today, Paradox Lab and you have explored the journey home of the Shenzhou 12 spacecraft, as well as China's plan to build the Tiangong space station. Hope you had a fun time watching the video, and now please continue to choose the video on the left or right of the screen to keep exploring other mysteries of the universe with Paradox Lab. See you guys in the next videos.